Thank you, everyone, for coming tonight. We're so excited to see you here. We hope you're excited to be here and to start the self-driving car nanodegree program. We have over 100 people here tonight, over 1,000 watching online, and everybody's really excited about self-driving cars. We started this 7 months ago when I joined Udacity in July. I came over here from Ford, and Sebastian said to me, let's try and build a self-driving car program that helps students do something similar to what I myself had done, which was go from being a normal web software engineer working with Ruby on Rails to take a bunch of online courses and claw my way onto an autonomous driving team, in my case at Ford Motor Company, which is a wonderful company to work for. And our goal is to help all of you who are interested in doing that to do that as well. And some of you don't want to do that. You just want to learn about self-driving cars, and that's terrific too. But we're really here for you in order to help you learn what you want to learn and achieve the goals in your career that you want to achieve. And we're really grateful that you're spending this time with us. We know it's a big commitment. It's a lot of work. It's a lot of work for us to put the course together. It's even more work for you guys to complete it. And your time is valuable, and we really appreciate you making the effort to learn about self-driving cars with us. Thanks so much.
Thank you. And in case you didn't catch it, this is David Silver, one of our instructors for the program. But you might already recognize him, so I mean, he's a celebrity basically. I'm Lizbeth Ortega. I do the community management for the self-driving car nanodegree program. So you may have seen me on Slack, have poked around the forums, maybe a Facebook group. And I'm also organizing events like this to get students together. So yeah, I actually wanted to show you what we're going to be doing tonight. Approximately. So times are approximate. We'll be flexible. 5:15, Ben Stinnett of Auro Robotics is here, and he's going to be sharing his work with autonomous vehicles. Approximately 6, we're going to have a Udacity Team Q&A, so you'll get to ask David and Ryan questions about the program and the actual content. And then 7 o'clock, for those of you here in person, we'll head over to Pacific Catch to hang out and have some good snacks and drinks. If you didn't already get one, there's tickets, little blue tickets on the back table. That'll get you a drink. So I will pass it on to Dhruv. Wait, sorry. One last thing, sorry. This is our catch box. We're going to be using it for Q&A. The way that it works is it's soft, so you can throw it. So whoever's taking questions will just point, and whoever has it last can either throw it if it seems like it makes sense or pass it along. And you just talk into the top here. Thanks.
Okay, thank you, Elizabeth. My name is Dhruv. I work on the self-driving car, AI, and deep learning programs here. You'll see me on Slack and stuff also, so if you have any questions, feel free to reach out. What we're going to be doing today is we're going to be able to hear from Ben. Ben works at Auro Robotics, and they run self-driving shuttles in Santa Clara University campus. They're live. People on the campus are taking them right now. And what's also really cool is someone who is taking the nanodegree is working with Ben and his team at the moment. So it's a real case of someone learning from us and then going and applying it in the field. So with that, I'd like to introduce Ben to come up and talk about what Auro Robotics is doing. So thank you, Ben.
Thank you for that, Dhruv. It's great to be here with you all. Perfect. Thank you. As hiring partners of the nanodegree, we're obviously super passionate about this program and about the curriculum that the team here at Udacity has worked so hard to put together for you because we are super passionate about the future of autonomous vehicles, the future of mobility, and we really believe that you guys are helping us create that future. So when we talk about self-driving vehicles, David mentioned Ford. Everyone knows the big auto manufacturers are working on it. There's Tesla, there's Uber, there's Google. What a lot of people don't talk too much about is self-driving vehicles for low-speed environments. So that's what we're going to talk about right now. So at Auro, we are working on reinventing campus mobility across private campuses by building self-driving shuttles that can really connect for that last mile of transportation in these private environments. So that's a picture of the vehicle that's currently running 5 days a week at Santa Clara University, 9 a.m. to 5 p.m. we would love to have you guys stop by if you're in the area and take a ride and ask our field engineer questions. So these low-speed electric vehicles kind of fall into a broader category that we've been calling neighborhood electric mobility. And this is sort of an area where autonomous cars are really starting to make sense, and municipalities and campuses are really sort of figuring that out right now. You've probably seen a few of these vehicles. You've probably heard about them in the news. CES, Navia, right there on the far end, did a small pilot project in downtown Las Vegas along Fremont Street. Ollie, of course, from Local Motors. They have a big name in the rapid manufacturing world, but they've put together Ollie as a shuttle-type vehicle that is currently operational, I think, in National Harbor, and they have a few other deployments planned in Las Vegas and maybe Beverly Hills, some other areas. And then Easy Mile, of course, is the big one for this area, with a deployment coming up soon at Bishop Ranch, which is a corporate park where they actually worked with regulators here in California to be able to deploy on these public-private streets with no driver. So really showing that municipalities and legislators are getting behind these sort of autonomous vehicles, where they say that passenger cars still need a safety driver inside of them and still need a steering wheel, a brake pedal, a gas pedal, all of those requirements. They've come along and said that these neighborhood electric mobility vehicles no longer require any of that. And you're free to deploy without a safety driver, without a steering wheel inside. Right now, that legislation is only for this Bishop Ranch area, but I think in the future, in the near-term future, we're going to see that spread across a larger portion of the country and of the state. So these low-speed electric vehicles, LSV is the low-speed vehicle, neighborhood electric vehicles. They have some use cases at places where you can probably imagine. The big one is these last-mile transportation solutions. VTA or BART gets you to the main transportation hub, but then a lot of people find themselves stranded. Definitely, if you have mobility impairments, if you have difficulty getting from that BART station to your actual final destination, that's where these really start to make sense. And then in areas where existing mobility solutions are expensive, they're cost prohibitive to implement and inefficient. And the example that we like for that scenario is on-campus environments. Many campuses across the United States, across the world, they have a fleet of manually driven golf carts which carry students with mobility impairments or faculty and staff all across campus according to their schedule, and it's very expensive. There's a huge cost overhead. You're paying for the vehicle, you're paying for the insurance, you're paying for the student driver, and those costs seriously add up. So what Auro is able to do is come in as a cost savings mechanism for these campus environments and provide an on-demand solution without the overhead. Auro takes care of all the vehicle maintenance, takes care of the liability insurance, and takes care of all the operations. Some other areas of interest here are retirement communities, corporate parks that Easy Mile at Bishop Ranch is going to sort of prove, theme parks, getting from the parking garage to the main gate, something like that, resorts, getting from the front gate to your room, to the different activity centers. All of these places sort of start to make sense, and then really heavily urbanized environments and smart cities that we're starting to see in places like Denver, and other areas around the country. I think we're going to see a lot more of these neighborhood electric vehicles. So why low-speed vehicles for these use cases? They're perfect for covering these shorter distances, especially in heavy pedestrian traffic environments that you see on college campuses, that you see in corporate parks, things like that. And especially because they have a smaller vehicle footprint. You don't want to put a Lincoln Mark II on a campus pedestrian walkway. You don't want to put a Chrysler van on a pedestrian walkway. But a small shuttle, and these are pictures of our shuttle that's currently operational, makes a lot of sense to integrate seamlessly into these pedestrian pathways that already exist. So zero infrastructure changes for the campus required. Some key specs of our shuttle. You can probably tell it's just a retrofitted golf cart. We've come in, we've developed the drive-by-wire and the sensor suite and, of course, the software, but it's totally modular. If you want the 4-seater, we can put it on a 4-seater vehicle. If you need a 2-seater, if you need a 12-seater, we can mix and match to get the vehicle that your campus requires. And with this actual vehicle, we get 90 miles per charge, which I think is pretty good. That allows us to do well over a day's worth of travel on the campus. Our current fleet, we can carry the 4 passengers as we see there and the 6 passengers in a different vehicle with a 25 mile per hour top speed, so that sort of matches Waymo's little bubble car and things like that. And the nice thing about retrofitting on top of an existing vehicle is that we get a street legal chassis, so that helps us overcome a lot of hurdles when dealing with regulations and things like that. So we've got a video here to show really quick. And this is sort of the promotional pilot video for the deployment at the university. In true Silicon Valley style, we built this thing in our garage over in Santa Clara over the last year or so. Some feedback there, sorry about that. And the campus here at Santa Clara is a bit small. Our loop there, we'll talk about it a bit more. It's just over a mile long, but we've really been able to integrate since November 14th when we started this deployment with the campus, and pedestrians have really found it to be a useful service. So Eric in the front, he's our field engineer that currently sits on the vehicle just to make sure he can intervene if anything happens, if any parts of the system fail. But all of the pedestrian tracking, the localization, the whole system has come together to allow us to deploy a vehicle. We'll be there until February for this initial contract, and then we're working on securing the contract for the next 12 months from there. So we can talk a bit more. I guess I have to wait for it to end. Oh, thank you. Thank you. Yeah, it's super exciting, I think, to be a team of 4 guys when we built this and deploy a shuttle, operational, making money, carrying passengers in less time than I think anyone ever thought possible before. And that really sort of also lends more credibility to this low-speed neighborhood electric vehicle market. The risk is a bit lower. We're traveling at these low speeds. Complexity-wise, it's a bit easier. So if you think about maintaining a point cloud, a 3D map of a downtown city center, lanes are constantly changing, construction is happening rapidly. In a campus, there's a lot more bureaucracy, which I think this is the one time that's a good thing. Because if changes are coming, we're going to know about it well ahead of schedule. We're going to be able to prepare for it, and you don't have sudden lane closures, sudden buildings popping up, screwing up your 3D map, which is a really nice thing for us. So like I said during that video, we operate along a 1-mile route. It's a loop with 5 discrete stops there that sort of hit the main pedestrian traffic points on campus. Number 1 there is like the parking garage that most of the students park in. Number 4 is sort of a hub for the sciences. Number 3 is the central mission that's on campus there at Santa Clara University. So it's been really exciting for us. We operate like a city bus on a fixed timetable. There's a lot of different operational modes that people are interested in with these neighborhood electric vehicles, one of which is sort of like the city bus. We have these discrete stops. We'll be there once every 8 minutes, 10 minutes, depending on the foot traffic that we have to slow down for. The other operational scenario is a lot more like the Uber style. We've got an app you can call for an on-demand ride. And then the other one is sort of more like a monorail, just maybe going back and forth, but on less of a fixed timetable. Maybe you're stopping, you're filling up, then you're going, like you might see at an airport or something like that. As I mentioned, Eric, our field engineer, currently sits in the vehicle. The vehicle itself doesn't have a steering wheel. You might have seen in the video. We do still have gas and brake pedals, but he can take over with the joystick that he holds in his lap, and he can control the vehicle. He can do an emergency stop. We deployed on November 14th, and since that time, we've logged over 1,500 autonomous miles. We've carried over 500 passengers, and it's been a really exciting thing for us. As you're all aware, I'm sure, there's sort of 4 key things that go into an autonomous vehicle. From my perspective anyways, you might be able to think of a few more critical ones. The first one is localization and mapping. The next one is sort of your scene understanding or obstacle detection. Path planning, obviously one of the more critical parts there. And then vehicle state monitoring. Is the driver in control? Is the system in control? are all my sensors reading properly? So we'll talk a little bit more about each of these 4 key points in more detail. So sensors and hardware, our main perception stack is the Velodyne, just like you guys have on the vehicle that you'll be actually able to deploy code on. We run the VLP16, which your Lincoln has on the front. You have the 32 on top, which is pretty nice, pretty sweet. They're hard to get your hands on these days. The LEDAR tech is this small little silver box underneath the front bumper. It's a 2D solid state IR-based LiDAR. Acts more like a proximity sensor for us to fill in any blind spots from the Velodyne. You can imagine with the Velodyne up top, you don't see very much of the rear. You don't see under that front bumper, so that allows us to say that we have 0 blind spots on the vehicle. And we have a forward-facing camera that sits right up next to the rear view mirror there. Other sensors that we rely on for sort of the localization and other things are the encoder straight on the motor, and then the IMU for some more odometry and orientation. Localization and mapping is sort of that first point we talked about. And we do this solely based on our Velodyne. So what we do when we show up to a new environment, we take the full point cloud, we store that, and we're constantly monitoring. That's all SLAM is, right? Simultaneous localization and mapping. And that gives us about 5 centimeters of accuracy. And I don't know if in your curriculum you have to develop your own SLAM algorithms, or if you use something that's open source. But that's a pretty hard thing to do. There's a lot of open source SLAM solutions out there. And 5 centimeters is really high level accuracy with no GPS. I should mention, that first list of sensors and hardware we saw, there wasn't a GPS on there because we don't use one. Campus environments, rainy days, parking garages, these all affect your GPS capabilities. So it's nice that we're able to say we work in GPS denied environments, which most of our competitors still rely on the GPS. The next key point here is scene understanding or obstacle detection. So what these 2 screens are sort of illustrating, the first one on the left side of the screen is our dynamic obstacle tracking, which is really critical in a heavy pedestrian environment. And I think you'll see through some of the different data sets that you work on, cars and pedestrians act very dissimilarly. They're very different beasts to tackle. And pedestrian heavy environments like college campuses have a lot of unknowns. You've got kids on longboards, you've got students on bicycles, and in between classes we're tracking 3 pedestrians there, but there can be as many as 50 in the field of view of the LiDAR, maybe even 100. And it becomes a very difficult challenge to sort them all, put them all on our cost map, and plan to navigate around them and avoid them. And the second screen capture there just shows sort of the Velodyne's perspective of all those obstacles during one portion of the route that we run. So that third point we talked about a little bit was the path planning. Once you understand your obstacles, understand the scene that you're looking at, you can begin to plan your route. If we're operating on a fixed route, city bus style, what we see here is more of a waypoint-based simple trajectory follower. Easier to implement, but you can't really deal with navigating in real time around obstacles. We slow down for them and stop for them and wait for them to move, as opposed to understanding where they're moving and moving around them ourselves. There's really 2 sort of planners that go into path planning. The global planner lets you do the high-level route planning from point A to point B. The local planner handles your obstacle avoidance, takes into account the pedestrians, and these are both, I think, really critical skills to solve problems in path planning for any sort of self-driving vehicle. And then that final point there, I think the remote might have died. There we go. Vehicle state monitoring. So understanding the state of your vehicle is very critical for safety. On our vehicle, this is handled by an embedded watchdog system. So some embedded side stuff comes into play there. If you've worked with Arduinos or TI controllers or anything like that, this is something that we rely heavily on. And we use that to monitor custom diagnostic messages from each of our sensors that we've worked out to understand, is that just an occlusion from the Velodyne? Is it a good Velodyne packet? And then it also handles the manual autonomous mode switchover. So if our field engineer has to take control, it's seamless. There's no lag, there's no wait time. It's all real time, handled by the embedded system. And so with that sort of overview of, I think, the 4 key problems of self-driving vehicles, and especially low-speed vehicles, I want to talk about the opportunities and some of the paths to working actually in industry. Because there's so many various paths to working in the self-driving industry. I myself took kind of a strange path going from the military to studying mechanical engineering, to coming in to Auro just as an intern, and then over the course of a year, getting to where I am now. So it's really goes to show you that experience outweighs your college degree. It outweighs where you come from or what you've done. If you're able to just solve these problems and apply your skills, it's going to be worth so much. And one key point of applying your skills is that you guys are going to learn so much during the course of your nano degree program, during the 12 weeks, is it? The 3 12-week trimesters or what have you. And one thing that I think a lot of hiring partners like Auro are catching on to is the idea that it makes a lot of sense for you to be able to apply those in the real world in real time as you learn them. So from the first cohort, we've been lucky to get a great intern who's able to come in and apply those skills and actually solve core problems for us. And I would encourage you all to seek out those similar opportunities because they'll make a really big difference. And then the other thing is that in those 4 sort of key fields, there's many problems yet to be solved or to be optimized. And I would encourage you all throughout the course of this program to find what excites you and really dive into it. Because when you're able to do that, when you're passionate about it, it sort of helps you gain that experience and will be extremely valuable in the industry. So with that, I'd be happy to take questions and talk a bit more about what we do. Perfect. Okay. Yeah.
Does it know when it has to stop and pick somebody up?
Yeah, that's a great question. So what I didn't have screenshots in there of is our mobile app. So that it has been distributed to students, and it shows you the ETA to the next stop, and you can request a pickup, but only at those 5 discrete stops. Otherwise, it's sort of like city bus style. Our field engineer in there is tracking people as they flag it down currently, but we'll begin relying on the app more heavily as we move forward.
How does it know when to leave?
So same way. So on the campus, we are required to ask passengers to wear their seatbelts, and we have to explain privacy policy terms and conditions really quick. So our field engineer takes care of that, and then just presses a button on the joystick. Yeah.
During this rainy weeks we've had, how does it perform?
So we've had 0 downtime during these crazy storms that we've had. We have had some issue with Velodyne occlusion from raindrops and things like that. Luckily, though, those are false positives, right? So when you have an issue with that, it shows up in your cost map as a false positive. So we just come to a stop. If it was a false negative or something like that, it'd be a much bigger issue. Yeah. Did you have something over here?
The catch box isn't working, so if you don't mind, you could possibly repeat the question.
Oh, repeat the question? Oh, okay. Perfect. Yeah.
So what happens if you take your system and put it in a unplanned, can it if you just put it in a desert, how does it start exploring?
Right. Okay. So the question was, what happens if we drop our vehicle into an unplanned environment? So we don't sort of do real-time SLAM. We make the map first. So our order of operations moving to a new customer site is we take just a handheld Velodyne, or we can drive the vehicle around, capture that Velodyne bag file or PCAP or whatever flavor you prefer, create the map, and then we're able to start running. Yeah. We use the same. So the question was, do we have a higher accuracy LiDAR? No, we use the same exact, the Velodyne, the VLP-16. Is there anyone over here? I was kind of focusing on this side more. Yeah.
How many cars do you have?
So the question was how many cars we have. So current fleet size, we have 3 vehicles, 1 of them deployed, with hopefully 2 more announced in the coming months. Yeah.
I have one from the live stream. Ian Bautista was wondering
Perfect. So the question was, what's Auro's future roadmap and our big goals? So really 2017 breaks down to true level 4, removing the field engineer and moving to a remote monitoring solution. It's something that's difficult from both a customer side and obviously a technology side. But I would say that's our main technological goal. We've gotten it down to a less risky enough point where actually customers are willing to hear about remote monitoring and the removal of a safety driver, which has been a huge sort of stepping stone to actually being able to do it. And now we feel comfortable that to say that by the end of 2017 we'll actually have no safety driver in the vehicle. Yeah.
You're using ROS. What version or what release?
So we're still on 14.4. What version ROS are we using? It's 14.4.
Well, that's Ubuntu.
Oh.
Like Indigo.
Oh, sorry. Yeah, Ubuntu 14.4, and we're on Indigo. Yeah.
And are you using like RTAB map or what planner are you using?
So Planner right now is pretty much custom for the trajectory follow mode. But TEB for local planner is something that we're definitely looking into. There's a lot of good ones out there, though. Yeah. Yeah.
Since November, how many times did the engineer have to take over?
That's a great question. So the question was, since the deployment began in November, how many interventions have we had from the field engineer? And the answer to that is a lot. And we're trying to be pretty transparent about that. Part of it is because of some restrictions placed on us by the customer site. So they're really worried about how, and we're also worried about how pedestrians will feel about having a self-driving vehicle on campus. Which is why we don't currently navigate around pedestrians. In the sort of fixed route trajectory follow mode, we just come to a stop. So anytime someone is having a drawn out conversation in front of the vehicle or something, we don't honk at them. Our field engineer will take over and manually maneuver around them. And the other thing is there's a lot of vehicles on campus, facilities vehicles, groundskeepers vehicles that like to park right in front of us. So the same is true. We'll have to maneuver around those. I don't have an exact number off the top of my head, but it's a lot. Yeah. Safety critical though, I guess I should differentiate. Safety critical interventions, something failed. The number is low, which I think is sort of the important benchmark for us.
And sensor failures?
We haven't had a sensor failure. No, we haven't had, in terms of like actually having to like have downtime and replace something. No, Velodyne, IMU, everything is what we deployed with and what we tested with for the last year. Yeah. Yeah.
So while the vehicle is moving, especially if going slow, can someone stop it?
So the question was, while the vehicle is moving, do we really have to come to a stop for a pedestrian to get in? The answer is yeah. So we travel slow. Our top speed right now is 7 miles per hour, which I think is a bit faster than being able to just like tuck and roll to get out of it or hop on. So we do stop. Yeah. Yeah.
We won't come to ROS until further on in the course. Can you talk a little bit about ROS and the role that plays in Auro?
Yeah, so ROS or the robot operating system is a really critical piece of the puzzle, I think. But it's not the only way to go about it. So it's what we use. There's other sort of frameworks or wrappers, or I'm not quite sure how you would refer to it out there, that are maybe just as good. But so ROS is sort of this great piece of open source software that I'm sure, is anyone here familiar with it? Has anyone worked in ROS at all? So I started with it back in like the early like DIY drones days and stuff like that, and in the research lab at ASU that I was working in. And it really has so many modules that other people are working to develop on it. Different nodes, different sensor integration and drivers there that have really made it just great for us to work in. Yeah. Yeah.
First of all, I'm really excited about your decision to operate in restricted, campus-type environments. One of your earlier slides kind of had a list of different kinds of campus-like environments.
Mm-hmm.
It seems a bit aspirational, given you have a couple of working vehicles now. But I'm curious if the decision to go on a university campus
was conscious or opportunistic? And if you had your choice, what type of campus environment would you go for? You know, you mentioned old folks, you know, retirement community,
Mhm.
or, I don't know, things like that. So I mean, could you discuss that?
Yeah, so I guess to paraphrase for anyone on the stream, the question is, what's sort of the ideal campus maybe for this tech? And I think you're right. The university campus, especially Santa Clara, it was in our backyard practically, and they are really sort of excited about the idea of being innovative in the heart of Silicon Valley and deploying this technology. So that's what sort of led to this initial partnership with them and the deployment there. I do think that university campuses, especially larger ones, maybe in the Midwest. I went to Arizona State, which I think is a great example. So the main campus there is a full square mile with 70,000 students on it. And they have a fleet of manually driven shuttles each day. It's called DART, the Disability Resource Center Transportation, where 8 shuttles all day, every day, getting people to and from class if you've broken your leg, if you have a long-term mobility impairment, something like that. And I really see that as an opportunity for us to be a cost savings mechanism for the university and provide a more efficient service. Where would I love to deploy, though? Probably a resort. Yeah, let's I wouldn't mind spending some time making a map down there or something. Yeah, that'd be good. Yeah, what is that?
Another question from the live stream. A student wanted to know how much time and expense do you spend on architecture, like system engineering, or if everything is done by trial and error?
That's a great question. So I guess what I didn't touch on was the brief history of Auro. Our 3 co-founders started a research group in India at IIT Kharagpur, where they got some funding to do some autonomous vehicle stuff. We're working on autonomous parking, things like that. In 2015, they applied to Y Combinator here in Silicon Valley and got accepted for the summer 2015 batch. After graduating that, we raised our seed round of just over $2 million, and that has gotten us to today. So we're coming up on the 2-year mark here. And originally, it was very much trial and error as far as our system architecture. We weren't even sure at the beginning if Velodyne was the right way to go, or if we should look at something like the IBO radar or some other perception like that. But now we're to a point with sort of having a fleet of vehicles where you can no longer be prototypey or hacky, where system architecture and planning is much more critical. So I would say, especially from like a leadership team perspective, it's become somewhere where we invest a lot of our time at this point, the steps moving forward and the technology roadmap for sure. Yeah.
The current Velodyne you use, how much does that cost?
So I think when we bought it, it was maybe at $7K, and now they came out with the HD model and opened up their new factory, I think here in San Jose or something. So hopefully we'll see that price coming down. The vehicle itself with the 12.4 kilowatt hour lithium battery pack costs like $30,000 from the manufacturer. We have sort of just a regular car lot customer relationship with them. We go and we purchase the vehicles like you would any other vehicle. And then the sensors to retrofit it in single unit quantities is about another $30K with the Velodyne, with the IMUs, with all the computational stack that we require. Yeah. So right now our main computer is a Nexcom automotive grade i7, 32 gigs of RAM. And then we also have a secondary, it's a Gigabyte Bricks, sort of like an Intel NUC. It's a small gaming form factor with like a mobile NVIDIA 970 or something in it, just to help handle some of the load. Yeah, in the back there.
So in terms of the underlying hardware and the sensors, what do you think are the innovations in those areas that can significantly improve the self-driving experience?
That's a great question. So the question was hardware, sensors, underlying system improvements that can most greatly impact the self-driving vehicle experience. I would say that answer is twofold. What will most greatly impact, our ability to produce self-driving cars is lower cost sensors, and I think sort of everyone in the industry understands that and feels the same way. we're super excited with the stuff that Quanergy is doing. We're super excited with the new mega factory from Velodyne, and hope that we just see the cost of these sensors continue to fall. From a user experience perspective, especially in these neighborhood electric vehicles, I think it's the little things. The drive-by-wire system. So we built ours in-house. That's the brake actuators, that's the power steering, things like that. Improvements there for our specific vehicle will make a huge impact on the user experience. Yeah.
Is the vehicle connected wirelessly and monitored remotely through the network?
So the question is, do we have like a vehicle uplink? Is it connected, and are we monitoring it in real time? Right now, no. So we do have a 4G modem on the vehicle, and the other nice thing about university campuses, to go back to your question, is that there's pretty much ubiquitous Wi-Fi on board. So getting data back to our office is not an issue, but it's something we have to carefully balance. So the issue with the connected car is now security and other things like that. So it's a goal moving forward. And in the near-term future, I think the answer to that question will be yes, for sure. Yeah.
So in the future, when you guys have these vehicles all over campus, do you envision having any sort of issue with cross-chatter between Velodyne and sensors?
That's a great question. Yeah, and you start to see some of that even if you put the question for the people on the live stream was, as we move to a fleet of these vehicles on a campus, do we anticipate having issues with cross chatter or noise between the different sensors and the different vehicles? People have dealt with that sort of issue, even with just multiple lasers on one vehicle or on one system. I think the operational strategy for our vehicle has them distributed enough that it won't be an issue for us. But it might be. I mean, we can't rule it out for sure. Yeah.
So, is the cost per vehicle is around $70K based on the numbers you mentioned?
Correct. Yeah. So the cost of the vehicle at unit quantities. So that's building one at a time. Which is a number that we're pretty proud of, right? Even building one-offs, I think that's a much lower number than most other self-driving vehicle companies can claim. And it really is what drives our ability to be a cost savings mechanism for the various campuses we deploy at. Yeah, Elizabeth. Oh,
Testing.
maybe we got.
Yeah.
Oh, there we go. Okay, the box is working.
So I have another question from a couple of students online. A couple are wondering if there's remote opportunities with Auro, if there's internship opportunities. I guess if a student's interested, what can they do?
Perfect. Yeah. So that's a great question. Remote is a bit difficult in a small team working on robotic hardware like this, but it's something we're always open to. So I would say, like, my general pitch, auro.ai is our website, or you can shoot me an email, and that's just ben@auro.ai. If you're here, I have cards, but if you're on the live stream, you'll have to take note of that. But yeah, we'd love to hear from everyone. I think our website right now will direct you to our current open positions. Most of those only list full-time, but if you see an area to work in that interests you, we'd love to hear from you. Yeah. Yeah.
If you have a fleet of vehicles operating and they could exchange their data that they see around themselves, would that help? And if so, what would be the enabling technology?
That's a great question. Yeah, so the connected car is something we talk a lot about in the self-driving vehicle industry, and especially in high-speed vehicles in cities and highways. It seems like it's something that will make a huge difference to the ability to plan and assess an environment. It's something that we need to give some more thought to. I think we're dealing with structured enough environments that trying to communicate both with our remote monitor and with the fleet of vehicles at once might get a little hectic, I guess might be the right word. So putting in place the architecture for that is something that's going to be critical.
What kind of diagnostics cost
That's a great question. So the question is, what sort of logs? And I think this will be our last question, Lisbeth?
Yeah,
okay.
cool.
Just so we can have time for everything else. So that's a great question. Yeah, I guess the answer is like almost everything. I think we are collecting like 200 or 300 gigs of data a day. That takes almost all night for us to offload from the vehicle onto our servers, and then we have our field engineer right now. He annotates it, so he has both his screen that is sort of like a debugging screen that has RViz, and it has all of the terminals on it for him to see like our CAN messages in real time and things. But then he also has a touch screen where he can quickly sort of just earmark important points in the log files to categorize different interventions. So that's how we're able to track, is he just moving to avoid a parked vehicle, or did he take over control because something catastrophic happened? But apart from like actual vehicle diagnostics, which is everything that comes across the CAN bus, all of the communications, all of the sensor feedback, all of the raw sensor data. We also, it's really critical to collect sort of user experience feedback and things like that. And those sort of metrics are something that we're starting to track more closely. So with that, I'd like to thank you all so much for being here. It's really been a pleasure, and I'll stick around, so please feel free.
Thank you so much. So we're going to move on to the team Q&A, which is going to be with Ryan, if I can invite you up. Actually, can you come down the aisle so we don't cross the camera? Sorry. And David. Yes. And we'll have an open forum right now for questions about the program, curriculum. They've been hard at work creating the program, so they're kind of your go-to people to answer these questions. I'm getting some feedback.
Any questions? Yeah, so the question was, are Ryan and I both local? We are both local. Ryan is even more local than I am. Ryan lives in Mountain View. I live in San Mateo. So, yeah, come by for breakfast, dinner, lunch. Actually, we're here for lunch and dinner and breakfast. Yeah.
So all the other Udacity classes I've taken have used Python 2.7. This class is using 3.0. Why the difference?
Yeah, so the question was, why do we use Python 3 when all the other classes use Python 2.7 at Udacity? We were a little pushy. We wanted to have kind of... I wish I had the engineering team here to hear that, or the website engineering team. Yeah, we just wanted to use the latest and greatest stuff. There were some issues with TensorFlow, and as some of you I've heard have struggled with as far as getting all the various software packages installed and working together. When we looked at what we needed to put together to make the coursework, it just seemed like being on Python 3 is the way to go, and the good folks who run Python say not to use Python 2 anymore if you can avoid it. So we avoided it.
So I guess I'm on the other side because just a comment, I started saying I'm not going to be able to get this on Windows, I'll do it on Ubuntu. And I struggled for a while, and then I said, well, I'm going to try Windows because nothing's working. And the script worked beautifully. You just ran Anaconda and everything the only thing you wanted to make sure is, I take that back, you want to get rid of Anaconda and run Miniconda, and then everything just flows beautifully. On the other side, the comments by the guy from Mercedes-Benz on the the optional lecture on the I can't think what it's called, the jobs, the career group. He emphasized C++, which sort of threw me a little bit. I mean, I know there's a lot of people out there doing it, but why? I'm thinking, this is to make an impression for people. Why would Udacity put this out there unless there's something I'm missing?
Yep. Do you want to field that one?
Well, basically,
Let's repeat the question first.
yeah. So, okay. Well,
I'll have to paraphrase a little bit, but basically it was Windows is just a fine operating system to install your programs and get started on. But the question was relating to, we have an interview in there that many of you may have seen by now with Axel Gurn from Mercedes. And he mentions specifically C++. And of course, for systems that are actually going to be driving an autonomous vehicle, you'll be writing C++. It turns out that a lot of the things that we need to do, at least in the first term, you could do either in Python or C++, but it's just a lot easier in Python, and it's a lot more intuitive to write. And we are going to get to C++ in terms 2 and 3. But basically, for making term 1 as intuitive and approachable as we could, we're just sticking with Python entirely. There's going to be both Python and C++ in the later terms, but basically, yeah, we're sticking with Python in term 1. Mm-hmm. Yeah?
Given that we're the 4th group to begin, how much have you changed the program so far, learning from the first 3 groups, and what kind of changes maybe the whole group expect?
Sure. So the question was, given that this is the 4th cohort to start, what kind of changes have been made since the first cohort started back in October? And so, in general, there are a lot of changes. I can't even begin to tell you exactly how many there were or exactly where they are, but the course started out with all the big concepts there, but with some gaps. And so one thing that we definitely want to encourage all of you to do as you're going through the course is to be in touch and to give us feedback, because that's how we've made the changes that we've made is well, through testing it out ourselves, but also through getting feedback from students who've gone through it. So basically, the changes that have been made at each stage of the program, we've tried to just clean up the gaps, make everything more intuitive, as interactive as possible, so that at each stage you're not just hearing a bunch of stuff, but you're actually able to try it in quizzes and in other interactive things. And so basically, I don't know. Do you want to add to that? It's pretty vague what I'm saying, but ping somebody in the October cohort and ask them what's changed.
I can add something. So, one of the big pieces of feedback we heard was that our deep learning section wasn't quite deep enough in terms of how much content we were covering. So we went back, added a lot more coverage into the intuition behind ConvNets. We put a lot of programming quizzes in TensorFlow so that you're actually writing TensorFlow in the browser. We've added walkthroughs on how to actually do the traffic science projects, so that it's a lot more hand-holdy for the first one, and then we leave you to the dogs on the third one. And then we had a lot of issues with the simulator, which we fixed up and we've made a lot better. So I would say we've addressed a lot of the deep learning content gaps that were brought up, and we've also added more content since. So those are the main things.
Yeah, so more and better, I would say.
Can you tell us a little bit about the final project, like what you have to do, what's expected good?
The question, yeah, is to elaborate on the final project. And you mean the final project for the end of term 3, like the end of the nanodegree program? Okay. I mean, David, do you want to take that one?
Sure. Yeah, so there's a not-so-secret about this nanodegree, which is that we are building it out as we go. So I was actually at NVIDIA yesterday talking with them about how they're going to help us build out the final project. So the way it's going to work kind of at a high level, and we're working on the implementation right now, is that you all are going to get to form teams with other people in this room and people online, other folks from this cohort. We're thinking the teams will be about 30 people, and each team will get to build code and put it on the actual car. We have a car outside. We might get other cars, and try and drive that car around a test track. In order to do that, you'll need to make heavy use of ROS, actually, what Ben was talking about, Robot Operating System, which is a type of middleware that helps self-driving cars run. It handles a lot of the publish-subscribe architecture that you need to input sensor data. It also comes with a lot of predefined packages that help make coding a self-driving car easier. But it's a lot more than simply just plugging a few pieces together and hitting go. There's a lot of gaps to fill in, as Ben was alluding to. So that's kind of at a high level how it's going. The first group of students will hit that in about August. You guys will hit it in about December of next year. So the weather will be worse for you. But I think we'll have all of the problems ironed out by then. We're really excited about it. This is something that we think of as an only at Udacity experience. It's not something that you get to do anywhere else. Maybe not even at a university. Actually getting to put code on a vehicle and then being able to go into job interviews and say that you worked on a team that actually built a self-driving car. So it's a lot of intimidation for us. We're nervous about it, but we're also really excited about it. I think it's going to be an amazing experience for you all and really help you all as you go out into the job market. Yeah.
Do you guys help at any point in the course about, like, if I have to either retrofit an old car into a self-driving car? Like, if I buy the lidars and stuff like that, because I think what I was reading is that the lidars are now down like $1,000 or $2,000. I think the price is coming back. You really build your own GPU rack. I think so. It's like getting the DTX1. But that's what I would really love to do, or even build out a toy model and just let the coder test it out.
So there's a question about will we help you build your own self-driving car? So we have, for legal reasons, stayed a little bit distant from that. I think it sounds like a really neat project that I would never advise you to go do. You definitely didn't hear that here. But yeah, ultimately the goal of the course, kind of our guiding star, is helping students learn what they need to know in order to get a job in the autonomous vehicle industry. We understand some students have different goals. Some students want to build their own self-driving cars or maybe start their own self-driving car companies, and we hope to help you with that. But we don't actually have a section of the course that kind of goes through, here's the bill of materials. You need to turn your Ford Fusion into a self-driving car, and here's how you plug it together.
Could you say how you did your car?
It's a good question. Actually, we've talked about that a lot, and I think we're going to get there, but for those liability reasons, we're kind of slow walking a little bit. We don't want to get anybody into any trouble, including ourselves. So watch out for it, but it's not something we're going to release quite tomorrow.
It could be worth mentioning the challenges and stuff.
Yeah. That's a good point.
So with regard to the car that we're building out, students have been involved in challenges to implement certain pieces of the software for that car, and there are a whole bunch of students in. So there are two different Slack teams. There's NDO13, which is the sort of code name for this nanodegree program, and then there's the Slack that all of you will be using, interacting with other students. But in the NDO13 Slack, if you haven't checked it out, you should check it out. That's where Mac and Eric, who are actually building out this car, are interacting with students, posting challenges and other things where you can get involved in the process for building our car. And you'll find other people in that channel who are enthusiastically doing their own projects, and so you can connect with them. Yes?
What about a simulator? It seems to me somebody came up with an idea of using Grand Theft Auto or something like that. I mean, it sort of got me thinking that there must be a way to kind of take a sort of virtual world where you can randomly get a computer to generate cars and pedestrians and things like that, and it gets harder as you go along to effectively build your own self-driving car.
Yeah, that's right. So the question is, what about a simulator instead of a real car for the purposes of testing out some of the software in an environment where you're not going to kill anyone? And in fact, that's what we're doing for the third project, and it's going to be implemented. We have a simulator that we're making better every day, and basically in the third project, what you'll do is use deep learning to get that car to drive itself around a track in a simulated environment. And then in future projects, we'll use perhaps that simulator or perhaps some modified simulator. But it's sort of like what you're saying, some people use Grand Theft Auto, we're using Unity. But that's a big part of the development of self-driving cars, a big part of testing out the software before putting it on the road. So that's part of the course. That's part of what you guys will be doing. Yeah. Sure.
Since there is an open source like simulated environment where there's pedestrian and a lot of companies are using it, forgot the name, maybe CP or something.
Cityscapes. There's some.
Cityscape, yeah.
Yeah, they've put out some big data sets. It's not necessarily a simulator, but it's a bunch of labeled data. Unless I'm missing something, maybe there's a simulator involved.
There's a simulator with pedestrian
Oh, okay. Well, we could check that out. Yeah, go ahead.
Yeah. Oh, so we looked at a bunch of different simulators. We talked to a bunch of different simulator companies. One of the challenges that we face at Udacity is supporting all three operating systems: Windows, Linux, and Mac. Actually, one of the things I was thinking was nobody in the October cohort would have said that everything worked perfectly on Windows. That's come a long way. And so one of the reasons actually that we went ahead and built our own simulator was the difficulty in finding a simulator that would work for this course that worked on all three operating systems. But there are a variety of simulators out there that get used in industry. Ben may have opinions on any simulators they use at Auro.
These four cohorts we have approximately like 2,000 people, right? And what do you think of the job prospects?
Right. Well, so in the four cohorts, we have a total of, it's closer to 5,000, isn't it? Yeah. So the question is, what about job prospects for 5,000 people in the self-driving car industry? Well, it's an industry that's growing exponentially right now. And so the reason that we've had so much interest from hiring partners is exactly that they're all anticipating a huge demand for jobs. So will all 5,000 people get a job? I can't say that for sure. We certainly hope so. That's what we're here to do, and that's our main goal at the end of the day, is to get you all jobs in the self-driving car industry, if that's your goal. Not everybody's goal is that. So what you'll find a lot in the student body is that a lot of people are doing other work. They're just kind of interested in this, and so they're doing it as a kind of a side thing, or they just kind of wanted to check out the material. I can't say exactly how many of those 5,000 are going to seek out a job at the end of this. We're hoping that a lot of people are looking for a job, and because that's what's going to make our hiring partners happy, is if they can hire a bunch of great people. But do you want to add to that? Or?
Yeah, I'd ask, are these skills only applicable in the self-driving car industry? Are there adjacent
Right.
industries?
So that's a good added question. Are these skills that you're learning in this course only applicable to self-driving cars? And the answer is, of course, not. Everything that you learn here could be summarized as AI and robotics, and so that stretches to cover so many fields it's almost inconceivable. And the deep learning, computer vision, these types of topics, we'll be talking about them in the context of self-driving cars, but the things that you learn extend to all fields where those are used. So yeah, it's broad. Let's see, I think one more here that, yeah.
We got two.
Yeah, okay.
What are you guys going to do with the $12 million?
What are we going to do with the $12 million? Who's giving us $12 million?
400 times 5,000.
Oh, we're going to pay people to review your projects.
It's less of a joke than it sounds like, actually. No, this has been the most exciting nanodegree program at Udacity so far, just in terms of how much interest there's been. We're really lucky for that. There are a lot of costs associated with the program. It seems like, in the software world, everything is kind of marginal profit, right? You bring in $1, you keep $1 because software is free. But actually with this program, we're buying a car. We pay mentors, project reviewers, forum mentors. So it's we think of it as a really great value for the money, and whatever money is left over, hopefully they'll use to keep the lights on here. But thank you for paying it. We know, it's hard-earned dollars, and we really appreciate it. Oh, sorry.
Go ahead.
Yeah.
So, just piggybacking on the question that Dhruv said, skills acquired will be portable. So, being in AI field, this was the first nanodegree, and AI nanodegree came just after this. So, is it possible that the first term, which is computer vision and deep learning, can you port it over to another nanodegree if you're not very interested in specific AI use case of self-driving car? You are interested in general AI applications.
Oh, no, are you quitting already? It's Okay. So Dhruv actually can probably talk the most about the AI nano degree because he's living in that world right now. So if you want to come up and talk a little bit about how what we're doing intersects with what the AI nano degree is doing.
So the first term in the self-driving car is actually pretty different from the first term in the AI nano degree. First term in the AI nano degree is going to cover more foundational AI concepts like game playing, planning, logic, and self-driving cars covering computer vision, deep learning. In regards to can you switch, we haven't really come up with a plan of how all these really fit together. Can you like easily move between them? But I think the reality is there's enough that's different about them and there's enough that's unique to each term and each program that I'd say just learn as much as you can. So yeah, that's my answer.
Yeah.
Follow-up question on the hiring side. So there are hiring partners. So how is the connect going to happen between the students and the hiring partners?
Yeah.
From us or from the Udacity side?
Yeah, so we're actually planning that out right now for the October cohort who will graduate in mid-February from term 1. And what we are working on right now, in fact, tomorrow, we have, starting with as a recruiter whose whole job is going to be to help place self-driving car students with our hiring partners. It's going to be on the phone every day with hiring partners trying to figure out what open positions they have that match the skill sets of our students. And then we'll be surveying you as you get close to graduating from term 1 about what companies you're most interested in, what roles you're most interested in, and then trying to make that match happen. So we.
One more follow-up question. So given that you're still working on getting new things into this nano degree, so is there any specific hardware requirements in terms of laptop or the desktops we should be having, or the ones we have are going to work?
So.
Mostly in terms of the maybe graphics card or the.
Yeah, so there's a question about what kind of the minimum hardware requirements are for the course, and specifically about graphics cards. So to address the graphics card question first, because that's actually easier, there is no requirement to have a graphics card for the course. It does help a lot to use a GPU to train deep neural networks, as you'll find as you move into the deep neural network section. But in order to address that for all the many folks who don't have their own dedicated GPUs, we have worked with Amazon Web Services to give every student in the class a $50 credit to AWS, and we have very detailed instructions about how to spin up an AWS. AWS is Amazon Web Services. It's their virtual server system. How to spin up an AWS server instance that has a GPU attached and train your deep neural networks in the cloud on AWS, which actually is a pretty valuable skill to take to employers. So no GPU required. As far as what actual machine you need to have in order to log into AWS or run your own code samples, my recommendation is to have a machine that you're already comfortable developing code on. A Chromebook probably isn't going to work. In fact, definitely isn't going to work. But if you have a machine that you're comfortable working in and developing code on, then that should be sufficient. Before I take more questions, let me just check with Elizabeth wherever she is. Are we okay on time? Oh, great. Perfect. So many questions. Okay.
So is the Unity simulator that you guys use for term 2 or 3, or is that open source?
We are working really hard to make it open source. It is going to be open source. We have gotten stuck with a couple of assets that are proprietary, and we're trying to move those out of the simulator so we can open source it. We have someone right now actually working on trying to remake a couple of the things we need to remake so that we can open source the whole thing. Sorry, the question was about our Unity simulator, which you all will actually experience at the end of the deep learning module in this term. You'll use it to train a deep neural network to drive a car around a track in a simulator. You'll probably spend more hours with that simulator than you ever wanted. We hope to open source it. Well, we will open source it. Yeah.
Are you actively recruiting new hiring partners, and what does that process look like?
Yeah, so we are actively recruiting new hiring partners. It has actually changed a little bit since I joined in a really good way, which is we now have people coming to us and saying, I hear you guys have 5,000 students in this course. We really need to hire a lot of autonomous vehicle engineers. Can you send some to us? And so To some extent, we're kind of taking inbound requests and processing that. Some of it is going outbound to companies and contacting them. We have people at Udacity whose whole job is to sign up hiring partners and coordinate with them. And the thing we are really focusing on over the next probably 4 weeks is making the hiring partnerships work for our existing hiring partners. So that question of, how do we connect our students to our hiring partners? We want to make sure not just that we sign up as many logos as possible, but that the partnerships actually get students into jobs. So that's our big focus for the next month. Yeah.
I guess in parallel with the efforts of, rather to recruit hiring partners, is there any effort to get some form of accreditation for this course, sort of partner with an accredited institution to kind of, bring that about?
You want me to toss that one to you, Dhruv? Or I may be able to answer that as well as anybody. There is not an effort to become accredited. There are actually some pretty stringent legal requirements once you become an accredited institution in the state of California. And our goal is not to become a university or to become competitive with the university. That brings with it a whole set of issues that we don't think help our students the most. What we want to do is teach students, how to do things. Ben, just gave a presentation where he put up on the slide, experience greater than college degree. That's not true everywhere, but our belief is that there's a big demand out there among people to learn how to do things, and that's what we're focused on.
If we get stuck on a project or we just need help, can we come to you guys as the instructors directly, or do we have to go to the mentors first?
Yeah, you want to?
Sure. So you're definitely welcome to reach out to us. We're in Slack, we're on email, we're around. It's not like we're hiding somewhere and don't want to talk to you guys. That said, if you all contact us at once, it gets a little overwhelming. So there are the forums, where there's a whole bunch of questions that already got asked and a whole bunch of questions that already got answered. And so that's a great place to start if you have a question, to try to search for it on the forums. Oftentimes there's detailed instructions there on how to solve your problem. And then we have a bunch of mentors in the forum and watching the Slack channels. And usually what I find is that when I see a question that I think, oh yeah, I'm going to answer that in a second, as soon as I get after it, the mentors are already on it. So the mentors are great. You'll have your specific mentor you can reach out to, somebody whose name you know and everything, but you can also just get in Slack and kind of ping the channel, or if you know somebody who's helped you before, reach out to them. So it's really a great community for solving people's problems when they run into trouble with the project, or when you run into an issue with the lesson. Definitely when you run into issues that you think might be a bug, or something that's just wrong, or a content issue, then for sure ping us. There's also the waffle board. I don't know if you guys have checked out the waffle board yet, but that's a place where you can post issues, and we will definitely see them, respond to them, fix them, whatever it takes.
Which method do you guys prefer? Which form of communication do you guys prefer?
I don't know. What do you? We probably see. I don't know if I see it depends on what I'm doing, whether I'm going to see an email first or a Slack message first. But feel free to reach out either way. Do you have a preference, David?
Yeah, it kind of varies a little bit by function. Slack, I find, is more helpful for a conversation. If it's something that I kind of need to see and then come back to and do later, just having it in my inbox, like with email, is better. Well, I encourage you all to contact us. I'm david.silver@udacity.com. Send me an email, say hello. I'm at David in Slack. Ryan is ryan.keenan at Udacity. And who are you in Slack? R. Keenan? Ryan Keenan? Ryan-Keenan. Please do talk to us. We love to hear from you. I think the only thing is sometimes, if things are really busy, it might take us a while to get back to you, and we feel really bad about that. But please do talk to us, and we love hearing from you, and it helps us make the course better.
How is the Slack actually segmented? Because I noticed I'm part of NT0123. Is that our protocol?
Yeah, so that's a little bit confusing. Ryan kind of alluded to earlier, there are actually two different Slack communities. One is kind of public for the whole world that's interested in self-driving cars, and that's actually where Eric and Mac and Oliver and some of our colleagues who are working on building the Udacity self-driving car, they're working with students who are in the course and out of the course, and they live a lot in that Slack. There's this other Slack that hopefully you got invited to when the cohort started, which is carnd.slack.com, or you can also get to it at carnd.udacity.com, I believe. Elizabeth has the carnd.slack.com. And that's where Ryan and I live most of the time. That's only for enrolled students. There are channels in there specific to each project, to each module. Feedback channels, so you can tell us, what you think of the course, if something's great, if it's not great, and we're very responsive there. So please come say hello. Yeah.
What are the main blockers or bottlenecks preventing self-driving car become reality?
What are the main bottlenecks in a self-driving car becoming reality? Depends a little bit on who you ask. I think Ben just said the cost of sensors is a big one. Computational power is a big one, although I worked on the computational platforms team when I was at Ford, and so maybe I'm a little biased. But in general, just taking all this sensor data we have and processing it fast enough to make decisions in real time about the world, that's a big one. So what we kind of see in the world right now is Uber has self-driving car trials going on with the public in Pittsburgh. A couple of different companies have them going on in Singapore. Uber had them going on very briefly in San Francisco before they ran into some issues with the DMV. A company called Nutonomy is bringing them to Boston. And the reason these are happening in very narrow areas is because of the mapping problem that Ben alluded to, which is for a self-driving car to work as things stand now, it helps a lot to have a very detailed map ahead of time. And detailed at the level that it's really hard to do in a large area. Sebastian has these stories from when he was working with Google's self-driving car program about how 101 would just change entirely from the perspective of a high-definition map in about a month, because every night Caltrans is doing something on 101 that changes the way the map looks. And keeping that map up to date is really hard in large areas, and so as we see self-driving cars enter the world, they'll enter first in these very small little areas, and gradually the geofence, as it's called, will expand. That was probably sorry, that was a longer answer maybe than you were looking for, but computational platforms, sensors, mapping, all big hurdles. Yes?
This is sort of a general comment on that. The Waze, W-A-Z-E, method of keeping track of things where essentially I can see one smart self-driving car communicates back, and after you get a few of these, it says, hey, we hit this roadblock over here, don't go here for a while, and then you all get reprogrammed to either go around it or take another route.
Yeah, so that was a question, or maybe more of a comment about just kind of the network effect with self-driving cars, that if you have if a company has a lot of self-driving cars on the road, it can use those cars to map the area so that other vehicles in that fleet have a better sense of what the world looks like. And that's absolutely true. It's also kind of a challenge, but companies like Waze, which is now part of Google, have shown in the kind of more macro mapping world, the kind of Google Maps type world, that can work really nicely for finding traffic issues. And there are a number of companies, startups in particular, that are looking at how to do that at a kind of high definition LiDAR mapping type level. Yeah. So a couple questions. One was about, is it common for companies to hire multiple self-driving car engineers? It's very much common for companies to hire lots of self-driving car engineers. Companies are scaling up their autonomous vehicle operations really rapidly, and in some sense it has to do at a large level, kind of what's called the OEM level, so companies like Toyota and Ford and GM, self-driving cars are moving from the research divisions of these companies into the production divisions. And in the research divisions, these are kind of small projects that are worked on by teams of kind of PhD level tinkerers. And when cars move into production, there are all of these wickets, they're called, that they have to go through. And it's like a 5-year process between when a car kind of gets on the production schedule to when it rolls off the assembly line. And if there are problems in that 5-year process, there's no stopping the train. The train just keeps on going, and you throw more bodies at it. And so there's a lot of hiring going on right now to help move these vehicles from research projects into production vehicles that can actually be sold and used in the real world, and companies are scaling up like crazy. Sebastian likes to talk a lot about the $10 million engineer problem, which is that if you kind of do the math on GM acquiring this startup called Cruise for $1 billion and Uber acquiring this startup Auto, which is a partner of ours, for reported about $700 million, and how many engineers they had at acquisition. It's pretty expensive per engineer, and companies are trying to find ways to hire engineers for less than $10 million a head. So there's a lot of hiring going on. So that was the first question. Second question is about, is Ubuntu the standard? Some flavor of Linux is typically the standard for operating on autonomous vehicles. Often it's maybe an embedded type of Linux that's pretty similar to Ubuntu. Yocto is a common type of embedded systems Linux, but it's generally some flavor of Linux that operates on self-driving cars. Oh, all right. 2 more questions, or maybe we exhausted everyone? Okay.
Is any sort of like security ever with cyber threat and bring it back, especially with how do you use there? I mean, challenges are people are seeing in the real world and what's happening there.
Yeah. So So security, the questions about security, cyber threats. There are a couple of parallel issues. One is security and one is just safety. Functional safety, which is just making sure the vehicle doesn't crash and that if components fail that the vehicle's still safe, is a huge, huge issue. Going back a long time for automotive companies. Automotive companies are very, very good at making sure cars are functionally safe. Cybersecurity is kind of a little bit new because we're getting connected vehicles, vehicles that connect to the internet. Teslas, if you're lucky enough to have one, you drive one home. It'll upload all your driving data into the cloud and download the latest hardware updates, and that creates all sorts of cybersecurity issues. We're actually talking potentially with some partners about launching an elective module on one on safety, one on cybersecurity or auto security. It's a big issue. In some ways, it's closer to traditional internet security than it is to car-specific things. At some point, it kind of crosses the line when malicious people or entities try and do malicious things. It crosses the line towards more classic automotive safety. Last question.
You mentioned why OEMs might hire multiple different employees to do this kind of stuff. What other broad categories have you guys seen in terms of people hiring specifically for deep neural network tuning or for sensors or that kind of work?
Yeah, so the question's about what other types of entities hire folks with the skill set or the skills that we cover in this program. So some of them are fairly closely related to autonomous vehicles. So Airbus just announced that they're going to have self-driving air taxis sometime this year, and the drone industry in general has a lot of parallels to self-driving cars, albeit with all of the issues of aeronautics kind of embedded. Farm equipment is actually a surprisingly huge area for this. John Deere is the world's largest operator of autonomous vehicles. When you start to get into neural networks, the field really expands. There are everything from security companies, connected home, Nest type companies. There are natural language processing companies that use neural networks to do things like have a conversation with you on the phone and automate call centers. translation. There's like a whole area of neural networks that are deep neural networks that goes way beyond what cars do. We're very focused on cars here, but we did just launch a deep learning foundations nano degree. Dhruv is very involved in that. And if deep neural networks are your passion, that's maybe an exciting thing to check out too. Cool. Thank you.
Thank you so much, both of you, Ryan and David. Yeah, down the center aisle. So this is where we're going to be going now. We're going to break out over to Pacific Catch, which is only a 8-minute walk.